Hi everyone, this lesson is for geometry students. This is chapter 4, beginning trigonometry day 1. Today we're going to talk about constant ratios and right triangles, also connecting slope ratios to specific angles. So let's get started. Okay. Our learning targets are to recognize slope triangles given a line, and also angle measurements and ratios, students connecting specific slope ratios to their related angles, find missing sides or lengths of angles of right triangles, and also talk about geometric means and arc or inverse tangents. You will need a protractor and a calculator for today, so make sure you have that available. A little warm-up. Use what you know about the angle of a triangle to find the value of x and the angle in each triangle below. So what we remember about a right triangle or any triangle is that the sum of the angles is equal to 180 degrees. And if you have a right triangle or a right angle within that triangle of 180 degrees, 180 degrees minus that 90 degrees leaves you 90 degrees left for the remaining two angles. So that what that means is that x, whatever the value of x is, plus 33 degrees is equal to 90, not 180. I could say plus 90 equals 180 and then subtract the 90, not really any point for that. So we're going to take 90 and we are going to subtract 33. We're going to get x equals 90 minus 33, which is 57 degrees. So that means this is a solution, this is my angle. And if you're a box person and you're like, I would rather box it up, you need to box up the entire equation, not just the answer, because this is an equation, not an expression. For this problem here, also a right triangle, which means, yes, I can say 3x plus 2x plus 90 is equal to 180. But taking off this 90 degrees right here, what that's going to do is that's taking off 90 degrees out of 180, which is still 90. So realistically, this angle and this angle here, these two angles, their sum is 90 degrees. So what I expect from you is that you write that and you say 3x plus 2x is equal to 90 degrees. You have 5x is equal to 90 degrees. You're going to divide both sides by 5. You get x is equal to 18. And 18 is a value that you're then going to plug in for x, because not only do you have to find x, but you also have to find the angle measurements in each of the triangles. So one of them is going to be 2 times x, and one of them is going to be 3 times x. So 2 times 18 is equal to 36 degrees, and 3 times 18 is, 54? I think it's 54, yeah. 54 degrees, yeah. And we can also just say 90 minus 36 is also 54 degrees. Okay, so moving on. This is like the main point of our topics for today, our concepts, slopes and angle notation. So our slope of a line, that's your rise over your run. Rise over your run. It's what we call the change in y, delta y. This is delta y. That means change. Change means difference. Okay, so what we're doing is we're finding the change in y. So the go up, over. That's your slope. So usually and possibly in the past you've said, well, the change in y over the change in x, and your teacher told you that this is your slope. And that's what it is. You're going to subtract your y's. It's the difference, change difference. It's the difference in your y's over your difference in your x's, okay? So that's the slope. Slope can be rewritten as delta y over delta x, and it's just the rise over the run. And the slope indicates how steep the line is and also the direction. So if your slope is rising up, that means it's positive. It's going up right, it's positive. It's going down right, it's a negative slope. So for example, if I said y equals to 2x plus, let's just say 3. I'm going to start up at 3 right here. That's my y-intercept, which is this value right here from slope-intercept form. If you recall, y equals mx plus b. B being my y-intercept and m being my slope. So I'm going to start here at 3, and my slope for this value is what's in front of the x, not including the x. And that's a rise over the run. That's my change in y over my change in x. So this is going up 2 and then to the right 1. So for this line right here, this line which is going up right, that is a positive slope. Okay, so that's going up right. Similarly, if I had y equals negative 2x, and I'm going to start at negative, 4, and I would start down here at negative 4, and then I would drop down because my slope is negative 2 over 1, so that means I'm going to drop down 2 and over 1, because my rise is actually going down instead of up. Your y-axis is up or down. So this graph here is going down right, and so what that means is I have a negative slope. So that's going to check the upward or downward, leftward or right. That's going to give me the direction of my slope. So when a right triangle is oriented like this, like a slope of a triangle such as the one below, the angle the line makes with the horizontal side of the triangle is called what we call the slope angle. So see this value right here, that means theta. This right here is actually what I'm saying is theta, and theta represents an angle. It's just a symbol for an angle. And so what that means is that the horizontal, this line that goes straight across, that's my horizontal. And that line that is on the horizontal, that is where my angle is going to start. So my angle starts on the horizontal and then works upwards like that. That's going to be my slope angle, okay? The way you find that is given two values. It's a ratio, and it's given the rise over the run. You see the rise? This is my rise, which is delta y. So delta y over delta x, and this is my rise over my run, okay? All right, so what we're going to start here is this. I want you to get out a piece of graph paper or just a piece of line paper. Try to draw straight, and then that means you need a ruler if you don't have one. I want you to graph this line below. Now this is y equals 2/5 x plus 0. There's no value here, which means that I'm basically starting my graph at 0. That's 0, 0, because that's my y-intercept if there's no value there, okay? Now I'm going to go up 2, because that's my rise. My change in y over my change in x is equal to 2 over 5. Not the x, just the ratio, just the number. So the slope ratio is 2 over 5, which means I'm going to go up 1, 2, and then I'm going to go over 5. 1, 2, 3, 4, 5. So that means up to over 5, my point is right here. And so what I want you to do is I want you to draw a straight line connecting those 2 points of your slope ratio like this, okay? And in doing that, what that means is what I want you to do is to try to figure out what the slope angle looks like it might be. Now remember, what you're going to do is you're actually going to create, there's your angle, that's right there on the horizontal, okay? It's going to be up in there. And what your job is to do is to create a little right triangle within this, okay? That's what I want you to do. And given that information, I want you to try, there we go. What I want you to do is to try, given your take out your protractor. Let me take mine out. Where's my protractor? There it is. I want you to try to take your protractor and figure out what the measure of that angle is with your protractor, okay? So how you do that, if you don't know, if you've never used a protractor before, let me see if I can make this a little bit bigger. Possibly. Nope. Maybe. Let's see. I don't think I can. All right. So anyway, what we're going to do is we're going to put our protractor right here on the axis, right in the middle, just like that, because we know that this line from here to here is 90 degrees, right? So using your protractor, what you're doing is you're going from here to here. That's what I want you to do. So that value, whatever that is, that's the measure of that angle. That's your slope angle. Your slope angle goes from the horizontal all the way up. And it kind of looks like, let me see what that kind of looks like. It sort of looks like, now remember, this has two angles, right? If you notice, what you've got is the outside, and then you've got the inside. So if I See that right there? Okay, so it looks like to me it's about 28 degrees is what it looks like to me. And so just checking, I'm going to check something really quick. And it's closer to 21 is the angle. So it's just my graph that's a little bit off. But yours, when you do this, the angle is closer to about, and so see these little squigglies? That's an approximation. So it's about 21, 22 degrees is what I would guesstimate this is. So it looks like it's about 22 degrees, okay? And so you would measure this distance from here to here. That's your slope angle. That's your theta. Theta is about 22 degrees. And you say about because you're not exactly sure, and also you're probably rounding off as well. Let's do this again. And so I want you to graph the line that says y equals x plus 4, meaning this is my y-intercept at 4. So I'm going to go up 1, 2, 3, 4, and I'm put a dot there. And my slope is what's in front of the x. That's my change in y over the change in x. That slope is equal to 1 over 1, which means from my y-intercept, which is b, which is that 4, from that value, I'm going to go up 1 over 1. I'm going to go up 1 over 1. And so this line that I'm creating right here, okay, that's my slope. That's my line with that slope ratio. What I want you to do right now is I want you to create a right triangle so that you can find the slope angle. So let's do that. So in order to do that, you're going to create this right triangle like this, right? Given the points you have. And then what I want you to do is I want you to use your protractor again and try to calculate this little angle in here, which is the slope angle. We call that theta for right now. So again, take your protractor, take that out, line it up here, just like that. And I want you to try to figure out, what does that look like it could be? I'm going to roll this up like that. To me, it looks like more than 40. You know, you have to work that out. It looks like about 45 degrees, maybe 45, 43, 44, 45. So it's about, I'm going to say 45 degrees is what I get when I bring that up to the top. And so that's what I want you to do, is to practice that and see, make sure you can do that. Okay. So we have to find a side length of a triangle. When a side length is missing, that length is often assigned a variable, meaning if we have a triangle, let's say this, like here, and then here's my right triangle like this, okay? We call these, like, this is A, and I could call this B, and I can call this C, and I know a lot of people call the right angle C. It's not always the case, so don't get in the habit of doing that. As a matter of fact, I'm going to just change it right now because I don't want you to get in the habit of saying a squared plus b squared equals c squared, because they change the letters all the time. It's more leg squared plus leg squared for Pythagorean Theorem. So I'm going to call this b, and then here's c. C is going to be my origin at 0, 0. All right, so what that means is that and we use capital letters to represent the actual angles. So like I would say the measure of angle C is equal to, like that, and I give it some sort of degrees, like in our last one, maybe it was 45 degrees, and like that. And so you would say like the measure of angle B is equal to what? These are capital letters, okay? So that means that opposite the capital letters are their little letters, which are the sides, and we call those little letters. So that's a little b, little c, little a, okay? And we call, those are our side values. So you would say little a is equal to 10, or whatever its value is. Similarly, we use Greek symbols to represent angles. So you've been seeing me use this angle right here, which looks like theta. So we call that theta. Theta is this, and a lot of times I write it more like that, okay? But this is theta, and all it is it's an angle representation. It's a variable that represents an angle. Also, I use alpha, which is this one, alpha. I never really use beta, which is just this long extended B kind of thing. There's also gamma, and there's delta, and there's phi. And I don't really use any of those. Most often I'm going to use theta and alpha, but I do want you to be aware that there are other variables that, symbols that represent an angle. Okay? So these guys are using theta. So I'm going to introduce what's called the tangent ratio. So a tangent ratio is when you are standing at an angle, we're going to call theta, and there you are. Okay, here's your hair. All right, and so there you are at this angle, and this angle we're calling theta. You have sides, right, based on where you are. So if I'm at this angle right here, which is theta, the opposite side is opposite from where I'm at. So like if you were to create an angle with your arms like this is the angle right here. You're the angle. Your face is the angle. This is the angle. So then the opposite sides, like put your little hands at Terminator sides, that's the actual side opposite from your angle, all right? Now adjacent means next to. So that's like attached. See that? That's attached. So that would be the adjacent side, all right? So in order, the ratio that we're going to be using today, and there are other ratios, there's sine and cosine ratios, but the ratio that we're using today is the tangent ratio. And the tangent ratio says that I can take a tangent of some angle that they're going to give me, and this is going to equal the opposite side, whatever that value is, over the adjacent side, whatever that value is. So it's the opposite over the adjacent, okay? And keep in mind that you do also have this value, which is the hypotenuse. And the hypotenuse we're not going to deal with today because we're only dealing with the tangent ratio. And the tangent ratio does not use the hypotenuse. Sine and cosine use the hypotenuse, but tangent is only opposite over adjacent, okay? And so you can also just abbreviate that to O over A. It's like a TOA, okay? All right, so let's see. We're going to practice with tangent. So I want you to put yourself at F. So let's say here you are. You put yourself here at F. Remember, tangent is the opposite side over the adjacent side. And all I wanted the values opposite over adjacent, okay? So if you're here at F, what's opposite is 3. And the adjacent side is 4, adjacent meaning next to. And then if you move yourself and you put yourself over here at E, tangent of E is going to be the opposite side. Remember, this is different because now you're here. Opposite side is now 4 over the adjacent side, which is 3. And remember, you're not going to use the hypotenuse because tangent only uses the opposite side and the adjacent side. And then for tangent of X, here you are again, put yourself here, opposite side and adjacent side. So that would be 12 over 5. Again, do not use the hypotenuse for today. Tangent of Y, and now I'm going to move myself over, actually not moving myself, redrawing myself, and putting you over here at Y. So the opposite side is now 5 and the adjacent side is 12. So this is a ratio, all right? So now what we're going to do is we're going to take that information that we have. Remember, we don't have a hypotenuse, and I actually don't want it for today, for right now, actually just this problem. But what I want you to notice is that if you were here at this angle, right, at your slope angle, then what information you're trying to find is the opposite side, and what you actually have is the adjacent side. Now remember, if you have 3 pieces of information, right? You have 3 pieces of information. In order to solve, you need at least 2. You need 2 pieces of information, all right? So therefore, do we have that? So let's look at that. So tangent of the angle, remember this angle, theta, is equal to 35 degrees. So tangent of 35 degrees is equal to the opposite side over the adjacent side, right? So you're going to say tangent of 35 degrees is equal to x over 17. And so your job is to find x. Now, if you notice too that this tangent of 35, that's one term. So I actually have one term on the left, and I'm going to put a 1 underneath that, and I have one term on the right. And because I have one term on the left and one term on the right, then what I can do is cross multiply and solve. So I'm going to go 1 times x, which is x, is equal to this value 17 times tangent of 35. So 17 times tangent of 35 degrees. Okay, now with this information, what I would then do, is I want you to use your calculator to find the actual value of what tangent of 35 degrees is. So get your calculators out, and if you don't have a calculator yet, and parents are, or you have money, or parents are asking you to, or getting you a calculator, then I would recommend that you buy the TI 84 Plus or the TI Inspire. I do have some TI Inspires for passing out for students, so if you do need one, I recommend you get in touch with me and ask me for one. Okay, so using 17 tangent of 35. So here's the TI. This is a sort of screen for a TI 35, TI 84, I mean. And so what I want you to do with this, the screen is on the right. I want you to find 17. So we're going to type in 17, type that into your calculator, times, remember, this is y equals tangent, 17 times tangent of 35. Type in your tangent. Now the tangent button is right here. So you're going to plug that value in, and then you have 35 degrees. You do need to make sure that you're in degrees. So if you're not in degrees, then you need, see up here, mine is in degrees. But if yours says something other than degrees, let's say it says radians, then what you would do is you would go to this button right here that says mode, and you would click on that, and you would scroll down with your arrow keys, right? You would scroll up or down until you get to where it says radian or degrees, and you would go over to the right and highlight degrees and then enter, because you've got to be in degrees to solve these, okay? So I'm going to go back to my actual question, which says 17 tangent of 35. I do need to close that parenthesis, do that, and hit enter. And so my angle, my slope angle is 11.9 degrees. And so I'm going to go back to my equation here, and I'm going to say, well, x, there we go, x is equal to whatever this, see this right here, we just did that on the calculator. That is then, and because I actually rounded off, right, what was it, 11.9 degrees, so 11.9 degrees. And so this, you're going to box this up, okay, and you're done with that value. That's the value of x. I can, better yet, put that in solution set, okay? All right, moving on. Now let's find the value of a. Now there's a little bit different spot from the last problem, all right, because the last problem, is it? Nope, actually it's the same place. So we know that if we're here, all right, if we're here, then what we're trying to find is the opposite side. We have the adjacent side, and we have theta, theta being our angle. So you're going to say tangent of 11 degrees is equal to the opposite side. Remember, the ratio is tangent of theta is equal to the opposite side over the adjacent side. And so tangent of 11 degrees is equal to a, because I'm trying to find that value, right? I guess the letters, that's a bad letter. Let's call this x. That way you don't get confused with the a down here. So this would be, let me erase this part right here. And so this would be tangent of 11 degrees is equal to the opposite side, which is x, over 20. And again, one term on the left, one term on the right. We're going to cross multiply to solve. 1 times x is x, and then I have x equals 20 times tangent of 11 degrees. And so on my calculator, and I know I'm going to be rounding off, and so on my calculator, I'm going to go find tangent of 11 degrees, and I'm going to multiply that by 20. So again, take your calculator out, and I'm going to do this different now. I'm going to go tangent of 20. I'm going to type in 20. I'm going to close my parenthesis. Also, make sure you're in degrees. I'm going to get equal. So the tangent of that value is just 0.36, but remember, you still are multiplying that by 20. All right, so I still need to multiply that by 20. So then I'm going to just hit multiply down here on the right, multiply my answer by 20, and I get 7.279. So I'm going to round to the nearest hundredth, which is the 7, to look to the right of the 7. And if that number is higher than 5, then the 7 becomes an 8. So 7.28. So I'm going to go back to my slides. And now my answer is approximately 7.28. And that's the length, that value right there, that's the length of that side. Okay, so that's that length of that side. Okay, you can box that up after you put that in solution sets. You can also use what we call inverse tangent. Okay, it's like if you had an equation like 2x plus 7 equals 10, right? Plus, the opposite of plus is minus. So you would actually take the inverse of 7, that's what that's saying, in order to solve this problem, right? You would take the inverse. The inverse of add is subtract. Then you would have multiplication here, and the inverse of multiplication is divide. So those are inverses, as you're doing the exact opposite of the operation, okay? So what we have is an inverse tangent. So that means that, see this button on your calculator that says tangent to the -1 power? That's what we're going to be using. Because, first of all, two things for this problem. Number one, I want to change this point value. So I'm going to actually change this. Let's just solve here, because since we're only using the tangent ratio, so tangent of theta, or in this case we're calling it x, this is x here, which we're calling it theta, is equal to the opposite side over the adjacent side, which is this right here, which I actually don't have. So in order to find that first, what I'm going to have to do is Pythagorean Theorem, meaning because I don't have this value. So I'm going to say unknown. I'm going to call it t. T squared plus 5 squared is equal to 7.8 squared. So I want you to use your calculator and solve for t. So what that means is I'm going to get t squared plus 25 is equal to 7.8 quantity squared, and that is 60.84. And then I'm going to subtract 25 from that, and I get 35.84. So I have t squared is equal to 35.84. I'm going to get that number, and can you bring me my charger, please? And then I'm going to square root both sides. And square rooting both sides right here, okay, is going to give me t equals, I'm going to take on my calculator, let me show you how you would do that, okay. You would take the square root of 35.84. You give me my charger, please. 35.84. So I'm going to go 35. Actually, I'm not going to do that. I'm going to go square root of. So second square root of 35.84, okay, and hit enter, and I get 5.986, so 5.99. And so that value right here is approximately 5.99. So what that means is this value here, my little happy face here, is about 5.99. Okay, so now in order to find the angle, because ultimately my goal is to find this angle right here. So in order to find that angle, what I'm going to do is opposite side over the adjacent side, right? Opposite over adjacent. So I already have my 5. Okay, so I already have my 5, which is the opposite side. Now I need the adjacent side. So I'm going to go 5 over 5.99. And what that is going to do for me now is I'm going to try to solve for x. Now, remember how we were talking about inverses? Well, in order to isolate the x, okay, that means that you need to take this tangent and move it over to the other side of the equation and actually do its inverse. So what that means is now the act of bringing it over is the inverse of tangent. And so that's going to be what we call arctangent. It's the inverse. We don't say tangent inverse. We say arctangent. And I'm saying this, arctangent. That's what I'm saying out loud. This is what I'm writing. Okay, so you're going to say arctangent of this value, which is 5 over 5.99. 5.99, I think I got too many nines there. 5.99, and then close the parentheses. So we are looking for arctangent. And when you're doing an arctangent, an inverse, what you're actually asking is this one thing. You're asking, where is the angle that satisfies this equation? So I'm asking for the angle. What is the angle? Where is it? So in order to find that angle, I have to do the arctangent. So go back to your calculator, and I want you to find the arctangent button, which is right above the tangent. So you're going to go second tangent, and now I'm going to type in the value of 5 divided by, I believe it's 5.99. Close your parentheses, and also make sure you're in degrees, and then hit enter. And what this is telling me is that my angle is approximately, because I'm going to round to the nearest hundredth, 39.85 degrees. So that means that this value, let me get rid of this stuff right here. That means that my angle, okay, which is arctangent, angle is about, what did we say? 39.85 degrees. So 39.85 degrees. And so that's what we just found. That means that, what that means is inside here, right? Inside here, this angle right here is 39.85 degrees. That's what that means. And then, just a note, like right what we were doing in the beginning of class, if I needed to find that other angle within a right triangle, right? All I would need to do now is I would subtract that angle from 90. So I would go 90 degrees, subtract 39.85, so 39.85, and I'm actually going to get 50.15 degrees. So if that was a question, I also know this degree here, okay? So you can find both angles by just finding one. You do that, okay? Cool. Find theta, or the angle measure, given this value here. You have opposite, you have adjacent. So take a minute. I would just like pause the screen for a minute, and you try to do this yourself, because I want you to be able to do this. So pause the screen. I'm assuming you did that. I'm going to go on. So we have tangent of theta is equal to, right? Put yourself here. You have the opposite side. This is my opposite side. This is my adjacent side. Opposite over adjacent. So that's going to be 20 over 45. And, you know, again, we're trying to find theta. And every time you're trying to find theta, you have to use arctangent. So we're going to say theta is equal to, we have to move this tangent to the other side. That's the inverse of that. So that's arctangent. That's how you say that, arctangent. I know I'm writing inverse, but I'm saying arctangent. And I'm not also just saying arctan, I'm saying arctangent, the whole word, even though I'm abbreviating. Of 20 divided by 45. And I know a lot of kids will ask, you know, hey, should I reduce this? It's not necessary, because your calculator is just going to do that for you anyways. So we have theta equals this value, arctangent of 20 divided by 45. So again, you're going to go arctangent of 20 divided by 45. I'm going to close, oops, oh, let me do that again. Arctangent of 20 divided by 45, close your parentheses, hit enter. You have 23.96. That's my angle measurement. So because I rounded, though, I am going to change my equal sign to an approximate value, and I forgot the number, 23.96. So that's going to be about 23.96 degrees. And again, if they were asking you to find also the other angle, which is up at the top, which they didn't ask us, but if they were, let's call that alpha, just for fun, right? Let's call that alpha. So if I needed to find alpha, then I would say to find alpha, I would go 90 minus my answer theta. And so that would be 90 minus 23.96. That's theta. And so go back to your calculator, and you're going to go 90 minus 23.96. Get that answer. So that's 66.04 degrees. And so alpha is approximately that value, the subtract whatever I got, what I get, 66.04, so 66.04 degrees, and that would be alpha. So for this problem, I want to find this angle here. I'm going to use tangent again, but in this case, this is actually, if you notice, an isosceles right triangle. I'm hoping that you already know what that value is, right? So tangent of A is equal to opposite over adjacent. So realistically, I'm finding tangent of A, which is my degree, I'm going to put a little degree up there, is equal to 1. A is equal to arctangent of 1. Get that value. By the way, you're always putting yourself at that angle where you're standing. You are never going to put yourself at the right angle, ever. So we have theta, A is now going to be equal to arctangent of 1. And so take a minute and go do that. Find arctangent of 1. And by typing in arctangent, I mean, this should be common sense right now. Arctangent of 1, 45 degrees. Because, I mean, think about it. It's an isosceles right triangle, which means that this angle has to be 45 degrees because these are the same, which means that this angle plus this angle add up to be 90 degrees. And if the sides are congruent, then the angles opposite those are congruent. So if you're basically taking 90 and dividing by 2, which is 45 degrees. So my angle measurement is 45 degrees. And then also B is also 45 degrees. Okay, so all of these right here are just very quick little exercises in finding the angle measurement. So I want you to take a minute to do that. And in doing that, let's work on this. So we would say, because if you put yourself here, right, this is again my slope angle, and you're trying to find the value of x. X is a degree. And instead of x theta, if you prefer x degree, if you prefer to use theta, you're welcome to do that. So in order to find this angle measurement right here, we are given the opposite side and the adjacent side. So all of these are going to be set up as tangent of x degrees is equal to, this one is 1 over 5. This one would be tangent of x degrees is equal to opposite over adjacent. This one is tangent of x degrees is equal to opposite over adjacent. Same thing as this, but note to self, if you notice this, these are the same value. So you should know, even after you set this up, tangent of x is equal to 3 over 3, which is 1. When you're solving this value, you do just get 45 degrees because it is isosceles. Now for this one, though, x equals arctangent of 1 divided by 3. So I want you to plug these in your calculator and do that. Take a minute to do each one of these. We have arctangent of 1 divided by 3. I get 18, so x is approximately 18.43 degrees. So there's 1. We have this one. Arctangent, so this is going to be x equals arctangent of 2 over 5. And so x is approximately, let's do arctangent of 2 divided by 5, and I get 21.8. So about, if I rounded that, it'd be about 22 degrees. Okay. And then this one, which is 1 over 5, right, which is 0.2. So this would be x equals arctangent of 1 over 5. So x is going to equal arctangent of 0.2, and I get 11 degrees, so it's about 11 degrees. And so there's all your angles and your ratios. And these are very common ratios that you're going to see over and over again. 1/3, you're always going to get 18 degrees. 1/5 or 0.2, you're always going to get 11 degrees. 0.4, this is a 0.4, you're always going to get 22 degrees. And anytime it's a 45, 45, 90, or excuse me, yeah, 45, 45, 90, because it's isosceles, you're going to get 45 degrees. This one's a little bit tricky because we are solving for x. This is not using tangent. we're solving for x for this problem, and we are using the Pythagorean Theorem. Pythagorean theorem. And the Pythagorean Theorem, again, says a leg squared, so here's a leg, plus a leg squared is equal to the hypotenuse squared. So we're going to go x squared plus 7 squared is equal to this quantity, x plus 1, quantity squared. So let's do that. Again, I encourage you to pause the video, take a minute, pause the video, so that you can work these out. This one's going to be, and then start it again and check your work, 49. And then this is going to be x plus 1 times x plus 1. So we have x squared plus 49 equals, I'm going to FOIL, I get x squared plus 1x, which is plus 2x plus 1. Now, if I were to subtract my x squareds, these are gone. Those are 0. I'm going to subtract 1 from both sides. I get 48 is equal to 2x. I get x is equal to 24. And so that's what x is. So we found x. Just a note, sometimes they're going to ask you to find x, but also the lengths of the other sides, or even ask you for the perimeter, which is a great question. That's it. Start that test question. Perimeter. And that would mean that I would have to not only find x, but I would have to plug these values back in. 24 plus 1, which is 25. So I would say if I wanted to find the perimeter, 7 plus 24 plus 25, so what is that? 49, right? Plus 7 is what? 56. Done. Okay. For this problem here, we would find the area in the perimeter. So again, great test question. These are not Pythagorean triplets. And so what I would need to do, because to find the perimeter of the big blue triangle, I would need to have this side here, but I don't have that. So I have to use Pythagorean theorem. So I'm going to find this x, I'm going to find this y, and then I'm going to, find all the values I need. So to find x, we're going to go x squared plus 4 squared equals 7 squared. So x squared plus 16 equals 49. So I've got x squared is equal to 49 minus 16, and I get 33. So x squared equals 33. So x is approximately, well, if I give you a decimal equivalent of 33, it's going to be about 5.7. If the question says find the exact value, that would be the square root of 33. So this value here is approximately 5.7, or you would say square root of 33. Now to find y, I would then go 4 squared plus y squared is equal to 9 squared. So y squared equals 81, right? Move this over, minus 16. So 81 minus 16 is 65. So y equals the square root of 65. So y is approximately, I'm going to take the square root of 65 for an approximation, which is about 8.1. And so now 8.1 is here. So to find the perimeter, right, I would say that's going to be 9 plus, so I'm going to put a P here for perimeter, 9 plus 7 plus 8.1 plus 5.7, because that makes that whole line, right? These two makes one line. And what is that? 8.1 plus 5.7 is 13.8. So I know that this line right here, this whole line, is actually 13.8. That's fine. So we're going to go 13.8 plus 9 plus 7, which is 16, is 29.8. So my perimeter is about 29.8 meters, all right, because I'm in meters. Now, lastly, for my area, though, I know that for a triangle, area is 1/2 the base times the height, but my base has to be perpendicular to my height. So what that means is I'm going to go 1/2 my base. My base we already know is 13.8. So 13.8 times the height, which is 4. So I'm just going to use my calculator. 13.8 times 4 is equal to 55.2, but then divide by 2. And I get my area is equal to 27.6 approximately. And remember, this would be meters squared because we did, this is approximately, by the way, because we did round, these other two values. That's why it's approximately. And then when you're doing base times height, that's meter times meter, and that's meters squared. So for this problem here, they're asking us which side is longer. So that's kind of a tricky question, because if I want to know which side is longer, then I actually would have to know all the lengths of the sides that they're asking. So that would mean I would need to know what side AB is, which I don't know. And I would also need to know what side BC is, which I also don't know. But I do know this, that I would need, hold on a second, which side is longer? I mean, I could find that like this. I'm going to show you two ways, okay? So in order to find x this way, right, given this blue triangle on the left, okay, if I took this blue triangle on the left, I'm going to bring this, oops, I'm not going to do that. I'm actually going to move this blue triangle over here, okay? And what that means is this is 11 and this is 10, right? And I'm trying to find x. So I know that opposite and adjacent. So I can say tangent of 11 degrees is 10 over x. Now this one's a little bit trickier because the x is underneath, which means that, yes, I'm going to cross multiply. I'm going to go x times tangent of 11 equals 10. I'm trying to solve for x, so I'm going to divide by tangent of 11 degrees. So x equals 10 divided by tangent of 11 degrees. So given that value, I need to do this on my calculator and say 10 divided by tangent of 11 degrees. So I'm going to actually just clear everything out because we're starting over. So we're going to say x equals, for this, tangent, or 10 divided by tangent of 11. So 10 divided by, now before I type in tangent, I do need to put in parentheses. So tangent here of 11 degrees, close the parentheses twice, make sure you're in degrees, and hit enter. So we have 51.45, okay? So this value for x here is about 51.45, okay? That's that length right here. To find y, we're going to split this triangle up. I'm going to bring this down here, and I'm going to get, this is 10, this is 68. And so in order to find this value down here, which is y, all right, I'm going to also, again, put myself here, right, and go opposite over adjacent. So I'm going to say tangent of 68 degrees is equal to opposite over adjacent. And I'm going to cross multiply. I'm going to get y times tangent of 68 equals 10. Y equals 10 divided by tangent of 68. And then I'm going to type this into my calculator again. And in doing that, okay, I get y equals, is this again the same thing? I think it is 10. Sorry, 10 divided by tangent of 68. So 10 divided by tangent, parentheses, tangent of 68. Close the parentheses and hit enter, and that's 4. Ooh, 4.04. That is a very small number. And so that value right here is 4. And so I'm going to lose the y and put 4.04. 4.04. And so what they're asking me is which is longer, AB or BC. AB is longer. AB is definitely longer. Now, two things, all right? All right. So first of all, when I'm finding these angles, right, just a note, I could have said that 90 minus 68 is 22. And instead of putting myself here, I actually could have put myself here and said tangent of 22 degrees is equal to y over 10. And then just cross multiplied, right? 10 times 20, tangent of 22. I would get the same value, which is 4.04. I'm going to get exactly the same value. But the difference is is that I didn't have to do additional step. I could have just cross multiplied and I was done, right? Because if you type in tangent of 22 equals and times 10, you're going to get 4.04 again. And this would have been a lot easier and less steps. Secondly, if I had done that and I knew that this was 22 degrees, right? Additionally, 90 minus 11 is 79 degrees. So this angle up here is 79 degrees here. What that means is that you should know that the side opposite the smaller angle is always going to be smaller. If this is a bigger angle than 22 right here, I could have just not done any of this work and just said, hey, AB is across from the angle that's bigger, so AB has to be longer. That's just, I mean, that's it. You're done. We did explain our answer, but that's actually all you had to do. For this problem here, we're just doing a little review for this, and this is saying what's the ratio of a side of length AK. So we know this is AK, and this is NE, AK to NE. So that's going to be 24 to 96. Something that's kind of cool about your calculator, and I want to show you this, is this. If I said 24 divided by 96, 24 divided by 96, of course I'm going to get a decimal, but I mean, and that's 0.25, which you should know what that is. But aside from that, let's say you did, oh, I forgot. I can actually go to this button here that says math and say, hey, I want to make this into a fraction, and hit enter. And then look, it actually gives me a reduced value of my fraction. So again, these are really amazing calculators. I would always recommend you using these. Okay, so we know that our ratio is 1 to 4, which means that if my scale factor is 1 to 4, my ratio of perimeters also 1 to 4, my ratio of areas is 1 to 4 quantity squared, which then is going to translate into 1 over 16. And then the length of EC, we don't know what that is, so we're going to solve that, right? We're going to go 1 is to 4, which is my scale factor, as, see, 1 is to 4, as 7 is to x. So 7 is to x. Cross multiply, I get x equals 28. 28 is my answer for the length of EC. So what we have lastly is, or what we call geometric means. And a geometric mean is where you're comparing your sides. It's like a ratio between the sides. It's always also going to be positive. And so the way you do a geometric mean is you're saying like A is to X as X is to B. These are my two numbers, A and B. A is to X as X is to B. So if I was saying what's the geometric mean between 4 and 9, you're going to say 4 is to X as X is to 9. I'm going to cross multiply. I get x squared equals 36. And then I'm going to square root both sides. Normally, you would get plus or minus 6. But because we're talking about a geometric mean, which is basically a length of a side, okay, that means that we're not going to have a negative length. So geometric means are always positive. So that's going to be x equals 6. So if I wanted the geometric mean between 3 and 9, again, 3 is to x as x is to 9. Cross multiply, I get x squared equals 3 times 9, which is 27. I'm going to square root both sides, and that is not a perfect square. So I'm going to get x equals, I know that that's the square root of 9 times the square root of 3. So this is going to be equal to 3 root 3. And I don't recommend that you use this as a, try to find the decimal equivalent unless it asks you to. Otherwise, you can assume that your answers are going to be in what we call exact values, that are exact values, which means that you're not going to find you're just going to leave it as is. So the exact value of this is just 3 root 3. That's it. Leave it like that. For this one, to find the geometric mean, so you're going to go 5 is to x as x is to 8. We're going to cross multiply x squared equals 40. I'm going to square root both sides. Again, leave your answer as an exact value. Square root of 40 breaks down to the square root of 4 times square root of 10. that's 2 root 10. So that would be 2 root 10. Okay. All right. You might be asking, like, where does the geometric mean actually come from? It's from the altitude. So like if the altitude is drawn to the hypotenuse of a right triangle, you end up with 3 different triangles, okay? And all of these triangles are proportional to each other. That being said, you do this. You go base is to height. So it's like base is to height here as height is to base. And what that is basically is this here. What we have is these little triangles, right? So you've got this big triangle on the right, this big little triangle on the left, and then you've got the larger triangle, which is ABC. And that's where basically it comes from. All these little triangles are then going to be proportional because they have the same lengths, and the lengths are that they share a length, and their angles are going to be congruent. Okay, so in order to do that, you would say this. If you knew that HG is 6 and EH is 24, your job is to find FH. So you're going to do this. You're going to go base is to height. So you're going to go 6 is to X as X is to 24. And you're going to cross multiply. You get X squared equals 6 times 24. 6 times 24 is 144. So X equals the square root of 144, and the square root of 144 is 12. For this problem here, we know FH is 16. We know HG is 8, and we're trying to find that value. Again, base is to height as height is to base. That's your geometric mean. So you're going 8 is to 16 as 16 is to X. You're going to cross multiply. You get 8X is equal to 16 times 16. And I'm going to divide by 8, and guess what happens? One of my 16s becomes a 2. And I get X equals 32, and then I'm done. So this value is 32. And lastly, we know that EG, this whole length, is 27. We know HG is 3. Well, that means that's 24, right? We're trying to find FG. Ooh. So you have options, okay? Number 1, you can go base is to height as height is to base, right? Or you can make the sides of the triangles proportional. But I'm just going to do that. I'm going to go 3 is to X. Not actually, I'm going to use Y instead because that's the Y value in the middle. So I'm going to go, this being Y, because we don't know what that is. So 3 is to Y as Y is to 24. I get Y squared is equal to 24 times 3, which is 72. And I'm going to square root both sides. And I'm going to get Y is equal to the square root of 72, which is actually, root 36 times root 2, or 6 root 2. But I'm going to, so I know that value is 6 root 2, but I'm actually not going to use that, because if I know that this value here is the square root of 72, and I'm going to use the Pythagorean Theorem, that means I'm going to go 3 squared plus the square root of 72 squared is equal to my hypotenuse squared. And when you're squaring a square root, you just get the number. See, do you see, understand why I didn't do that? So x squared, so we've got x equals 72 plus 9, which is 81. X squared equals 81. So that means x is equal to the square root of 81, which is just 9. Oops. Ah. Whoops. Little, I don't know if I can delete that. Yep, there it goes. So that means that x is equal to 9. And we're done. So there's just a couple of other things that you can do, and there's like some applications and whatnot. The length of one side of a square is 6 inches, so we know that's 6. And if you're trying to find, like, let's say this length of the diagonal, if you remember, we did this in class before, right? 6, what's this? 6 root 2, that's the answer. But if you forgot, you would use Pythagorean Theorem, and you would say 6 squared plus 6 squared is equal to my diagonal squared. And you would get 36 plus 36, which is 72, is equal to d squared. So my diagonal is equal to the square root of 72, which again breaks down to the square root of 36 times the square root of 2, which is 6 root 2. And so the diagonal is 6 root 2. So from the beginning of this class, you guys did the slant angle. And this is just a few application problems. If you're looking at this and you're saying, well, I'm trying to find this slant. So this is called the Leaning Tower of Pisa. I've actually lived in Italy, so this is pretty cool to see this problem. We have the Leaning Tower of Pisa, which was a building, and now it's leaning. And the basic concern is that if the slant gets beyond 83 degrees, okay, then it's actually going to collapse. And so what they want to know is like, what's the value of the Tower of Pisa right now? What's that angle leaning at right now? So again, what you can see is, I'm just going to redraw this little triangle a little bit. And we're trying to find theta. That's what we're trying to find. But we know that this is 5 meters. And we do know that this is 50 meters. So again, this is a tangent value, right? Because this is opposite from where you are, right here, right? Opposite, and this is adjacent, okay? And so we're going to say tangent of theta is equal to the opposite side over the adjacent. And so to find theta, to find that angle, I'm going to find the inverse. And I'm going to say arctangent of, what is that, 10? And so use your calculator. You can do this and go arctangent of 10. And I get 84.3. 84.289. So 0.29. That's what I get. 84.29 degrees. And so right now, this is the degree that it's leaning. We're very worried that the Leaning Tower of Pisa is going to be no more. You got to be careful. 2 more problems and we're actually done. The base angles of an isosceles triangle. So I want you to draw an isosceles triangle. Isosceles, do a better job. The isosceles triangle looks like this, okay? And meaning 2 sides are congruent. The base angles are 55, so that means 55 plus 55, right? What's 55 times 2? 0, 1, 10, 11, 110. So if I know that the sum of the angles is 180 and I subtract 110, right? I've got 70 degrees left, so there's that value. What they want to know, though, is not that. They want to know the length of my altitude. And by the way, my altitude is always going to come straight down, perpendicular. Similarly, they told me that my base is 40 centimeters, which means that this, even though this length here is 40, in order to find this height, I realistically only need this side here, which is now 20, and I'm trying to find that height. Put yourself here, right, at the actual angle where you're trying to use for tangent. So we're going to say tangent of 55 is equal to the opposite side over the adjacent. We're going to cross multiply. I get x times 1, which is x, is equal to 20 times tangent of 55. I want you to do that. Tangent of 55 times 20, and that's 28.56. So x is approximately 28.56. That's the length, centimeters. For this problem, we've got application. It says draw a diagram and then solve. A tower, here's my tower, cast a shadow. Shadows are on the ground. Like I said, unless you're Peter Pan, it's on the ground. 35 meters. And when the angle of elevation, now the angle of elevation is the angle that you look, that goes up like that, right? And so here you are on the ground, I guess, lying on the ground, and you look up, okay? That's the angle of elevation. Angle of elevation is always on the horizontal. So this is going to be looking up. The angle of elevation is 32. How high is the tower? And so it is a right angle, because so you can use tangent. And so again, we have the opposite side and we have the adjacent side. And so you're going to go tangent of 32 degrees. You always put the degree right after that, the word tangent. Tangent of 32 degrees is equal to x over 35. I'm going to cross multiply. I get x equals 35 times tangent of 32. And you would use your calculator. I'll use this calculator for this one. Tangent of 32 times 35, maybe, there we go. Tangent of 32 is equal to, and then, oops, enter. Uh-oh, that's not right. Let me do that again. Clear. Tangent of 35, close that. I'm having some slight issues with this. Delete. Okay, try this again. 35, close the parentheses, and then I need to multiply, I think I need to multiply, oh, it's tangent of 32. Oh, that's why I can't see this. It's a little tricky. So let me clear this again. It's got the wrong angle. So we're going to go tangent of 32, close the parentheses, equals, and then I'm going to multiply that by 35, and I get 21.87. And so what that tells me is that the height of the tower is 21.87, 21.87, and to the nearest meter. So that would be to the nearest meter. Oh, to the nearest meter is saying it's about 22 is actually what it's saying, meters. If they want the nearest, I usually round to the nearest whole number, but if they want the meters, then that's what you do. So just a couple of pieces of vocabulary here. Road grade, you know, that's rise over run. So if I said 12%, that's 12 over 100. I can find theta because I have opposite over adjacent. Altitude is the height, and altitudes are always perpendicular. This is the angle of elevation, again, always with the horizontal, looks like this. A plane taking off at 25 degrees. Now, this is the hardest one, to be honest. The angle of depression, so like, let's say you're a plane and you're I don't know, 2,100 feet up, meters up, and you're coming in for a landing, and so that means you're going to start coming down, right? The angle of depression is always on a horizontal. So that's kind of tricky because it's not inside the triangle. The angle of depression is outside. There. It's that angle on the horizontal. So you know that the angle of elevation also is on the horizontal, right? So that's going up this way. That's my angle of elevation. Whereas this value is my angle of depression. Okay, so you've got to be careful with that. It's always on the outside. So if it has a 15-degree angle of depression, my angle of elevation, fun fact, also is the same value. Okay, and then lastly, the sun is 60 degrees above the horizon. You know, that's just your value 60 degrees up. That's from the horizon. So I guess I have one more, and I didn't realize I had an extra problem here, but that's okay. Let's just do this as a warm-up. And so we're going to go right to just make sure we did all of our learning targets. We did our slopes. We did our angle measurements. We did our geometric means and our arctangents. So we are in good shape, you guys. I hope you watch this video. Homework is the 2 worksheets, and also, hey, exit ticket, very short. Not 1 or 2 problems. No big deal. Thanks for watching. Thanks so much for watching, and I hope that helped you, for sure.